Hello dear students. In the previous video we have discussed about the dielectrics, and that time I have told that we have learned about dielectrics to introduce it in capacitor. What is the main target to introduce a dielectrics inside a capacitor or between the two plates of a capacitor? The main target is to reduce the electric field. If we able to reduce the electric field, then the charge capacity of a capacitors it will be increased. Okay, so how much capacitance will be increased by introducing a dielectric, that we have to see now. Okay, let's see. So I have already written the capacitors with dielectric. So first thing we have to learn here, number one, a dielectric slab of thickness T is introduced between two plates of capacitor. Okay, so thickness is mentioned here. Let's see how it looks. Assume this is one plate of capacitor, this is another plate of capacitor. So parallel plate capacitor, I have not done it this way, rather I have just drawn in a form of landscape, so it is easier for understanding. The distance between two plates is D. Okay, now we know in this point the positive charges will store. Okay, and here negative. Okay, so it is Q plus, it is Q minus. Okay, the earlier concept we have done based on the capacitor, so we have drawn it. Now we know the electric field is acting downward from positive to negative. The strength of the electric field I have written here. So we have starting answer. The strength of electric field without dielectric slab is E naught. So we are taking the electric field E naught is acting downward from positive to negative. So it is E naught. Now what we have done? We have introduced a slab of dielectric, right? And here we have mentioned the thickness of the dielectric slab is T, small t. Thickness of the dielectric slab, it is small t. So due to this, we know in the dielectric slab the negative and positive charges will just separate it. So the negative charges will come here and the positive charges will come here, and there will be an electric field is created inside it, that is EP. Why it is EP? Because we know it is occurred due to the polarization. Polarization means this positive and negative terminals are separated. That's why it is known as polarization. So due to polarization, another electric field has come, that is EP. Okay, which is exactly opposite to E naught. Okay, so the resultant electric field in slab zone means the dielectric slab, that is definitely E equals to E naught minus EP. E naught is acting downward, EP is acting upward, so it is E naught minus EP. If the dielectric constant is K, if you are assuming the dielectric constant is K, then E0 minus EP that is equals to E0 by K, that we have proved in the previous video, that E0 minus EP equals to E0 by K, and along with we have learned that is magnetic susceptibility, I'm sorry, magnet, no, it is dielectric susceptibility, dielectric constant, etc, etc. Actually, this dielectric is there for a thickness of T, and the resulting electric field, that is E, we have seen here, that is for this T zone. So in the rest of the zone, that is apart from T, the rest of the zone is D minus T. So T portion is occupied by the slab, rest of the zone it is not occupied by the slab. So we can say in rest of portion, that is in bracket D minus T, okay, potential electric field will be E naught, because there no dielectric slab is there. So only where the dielectrics, there only it is E, that is E0 by K, rest of the zone, that is E naught. Okay, now we know, okay, now you may ask him what we know. We know that electric field without dielectric is equals to E naught, whose value is sigma by epsilon naught. I have told several times that the electric field in free space due to a capacitor, that is sigma by epsilon naught, that proof I have given, that is for first plate, it is for infinite plate, it is sigma by 2 epsilon naught. Here it is also minus sigma by 2 epsilon naught. If you minus it, then it will come sigma by epsilon naught, that is the electric field. And now here we know that potential V equals to minus of E dot dr with the integration, that we know that this is a relation, but here we don't want to find potential by this method, because this method is little longer, and if we do it, whatever the answer will come, that we know. So that's why V equals to, we have to write down electric field into distance. Okay, so it is a easy method to, if you do by this calculation also it will come, but we have written directly result, otherwise that integration extra work you have to do. So you have to remember that V, that potential, that is equals to electric field into distance, So we'll go for the next part. Okay, if you have not written this portion, please pause the video and write it down. So potential V equals to electric field into distance. So here potential V equals to, see here two type of electric field is acting. One, it is D minus T zone, and another is in T zone. T zone means where the slab is introduced and where no slab is introduced. So in D minus T zone, that electric field is E naught. So potential V, that should be electric field E naught into distance. So what will be the distance where the electric field E naught is there? That is D minus T, and plus along with it the electric field in T zone. So in T zone the electric field is E into T. Now see this equation, you have thinking that from where we have written it directly. So if we have gone by this method also, it will come this at the end. But if you do it, then separately you will do for the potential this, you will do for the potential this, and then add. It will take a long space. So for that reason we have taken electric field into distance. So electric field E naught for the region D minus T. because d is the total distance, t is the slab, and electric field E into T. Now E naught into D minus T, and instead of E we can write it is E naught by K if the dielectric constant is K. We have already taken the dielectric constant is K, so instead of E we can write E naught by K into T. Now put the value of E naught, sigma by epsilon naught into D minus T plus sigma by epsilon naught K into T. So this is your potential you have got, and we know what we know now. Capacitance C equals to Q by V. Capacitance C equals to Q by V. Okay, so here what is Q? We know Q equals to sigma into A, where A is area and sigma is charge density. Charge density means charge per unit area. So here instead of Q we have to write sigma into A, and in V sigma by epsilon, if you take common then it will come D minus T plus T by K. D minus T plus T by K. Now sigma will be cancelled out, epsilon will come up. Epsilon naught A D minus T plus T by K. Now you see one thing. What is that? Now initially we have learned whenever there is no slab, okay, so then the capacitance is, so we have to write here, when no slab of dielectric, then C equals to epsilon naught A by D. Okay, epsilon naught A by D. And now you see, whenever we have coming here, we have some minus from D. D minus T plus T by K. So here you see, just this answer, T by K is definitely smaller than T. And that's why whatever the thing is there, whatever the thing is minus from D, that should be positive. That means the denominator is decreased. So denominator is decreased means the capacitance what is earlier, it will be increased. So if we introduce a dielectric slab, then the capacitance will automatically increased. Okay, then the capacitance will automatically increase. Now here one question will come. What is the question? Now instead of taking a small slab of T, if we have taken the whole slab, that means the full gap is just taken by the dielectric slab, that means size D. So here we have to mention that if it's a special case, okay, so you have to mention special case. What is the special case we are doing? That if the thickness of slab is equals to D, means instead of T, okay, we have taken a slab which is totally occupy the space, then T equals to D. If we put the value here, C equals to epsilon naught A by D minus, instead of T I have to write D, by K. So this dd will cancel out, K epsilon naught A by D. So you see, initially when there is no slab, then the capacitance is epsilon naught A by D. But when you introduce the slab, whole the thickness will be the thickness of the slab, then it is K times increased. So we can mention also that is C equals to K into C naught. So let's take it C naught. So K times the capacitance is increased if you introduce totally a full slab of dielectric, then the capacitance will be changed into K times of the capacitance when no slab is introduced here. Okay, whatever the things I have told, maybe it seems to be too hard, but if you see it several times, it is very easy. What is our target? Our target is very easy, or like earlier, we have to find the capacitance, so we need Q, we need V. Q, no, we can take that total charge is Q. V we have to find out. How we can able to find V? We have to find E first. So E into D, we'll get V, Q by V. Okay, so if you do Q by V, then you will get the capacitance, and here we have shown you a special case. Okay, this part is over. Now we'll go for the another part. Here we have introduced one dielectric slab. If I introduce two dielectric slabs, then what will happen? Okay, so our next target is to find out two dielectric slabs. Here we have written A dielectric. No. Now it is two dielectric slabs of thickness T and D minus T are introduced between two plates of capacitor. Two slabs we have taken. Now you might be thinking, what is this? Let me show the diagram. First and second plate. Okay, so here this is plus, and here this is minus. Here you have to introduce two slab. Total thickness, it is D. We have already taken earlier. One slab I have taken up to this. Okay, and here the thickness I have taken, it is T. And another dielectric slab covers the rest of the portion. So another portion will take D minus T. Okay, so here the dielectric slab I have taken, its dielectric constant I have taken K1, and another one it is K2. See, what I have done, I have not done any extra thing. Initially I have introduced one dielectric slab, I'm sorry. Here I have introduced two dielectric slabs, one for thickness K1, thickness T of dielectric constant K1, and another one is thickness D minus T of dielectric constant K2. Two dielectric slabs are introduced here. Now the question has, what will be the capacitance? Okay. Now it is clear, so I am not writing much thing here, otherwise it will take much time. So for K1, okay, for K1 let the electric field is E1, and for K2 the electric field is E2. Okay, so if we mention that E1, so what is E1? So E1 is nothing but E naught. E naught is what? If there is no slab, what will be the electric field acting? That is E naught and EP1. EP1 means for the first slab. For the first slab, what is the polarized electric field? I have seen earlier that due to the presence of external electric field, the dielectric slabs will be polarized, and the polarized electric field will be opposite to the external electric field. So that's why we have minus here, and the resultant electric field is E1. Okay. And if I'm talking about E2, that is E naught minus EP2. Clear? This E1 can be written as E naught by K1. We have learned it earlier, and it is written as E naught by K2. That means that electric field can be represented by the electric field is divided with the dielectric constant. Why? Because earlier we have learned that electric field, the external electric field by the electric field which is created, that is the resultant electric field, its ratio is the dielectric constant, that we have learned earlier. So that's why E equals to E naught by K1 and E2 equals to E naught by K2. We know what is the value of E naught. We know that E naught is equals to sigma by epsilon naught. It's very common. And now electric field we got. What we have to find out? We have to find out the potential. So potential V equals to, we know that is electric field into distance. Electric field into distance. So electric field into distance, if you write here, so for the first case it is electric field E1 and its distance is T, and next case electric field is E2 and its distance is D minus T. So if you just multiply electric field into distance, then you will get the electric potential. Okay, so if you want to see an example, I am telling you, for the point charge, if it is a charge q at a r distance, the point charge, you want to find the electric potential here at the point P. So you know the electric field equals to E equals to Q by 4 pi epsilon naught r square. And if you find the potential E into distance, if you do it, then it will Q by 4 pi epsilon naught r square into r. So it is Q by 4 pi epsilon naught r. We have done it earlier. Then you might be thinking, sir, why you have not told it earlier? Why you have calculated so much? Otherwise we can directly write down it. See, we can directly write down it whenever we have know the original calculation. Then only we can do it. Okay, so forget it. It is only to show you, nothing else. Now, E1 equals to E naught by K1 into T plus E naught by K2 into D minus T. E naught by K1. E naught means sigma by K1 epsilon naught into T plus sigma by K2 epsilon naught into D minus T. Again, we have to find capacitance. So capacitance C equals to Q by V, and again you know Q equals to sigma into A, that is charge density or charge per unit area into area. So put the value here. C equals to sigma into A by, it is the potential, that is sigma K1 epsilon naught into T plus sigma K2 epsilon naught into D minus T. You see the sigma will be cancelled out and epsilon will be come up. So epsilon naught A by T by K1 plus D minus T by K2. Okay, so this is the capacitance whenever we have introduced two dielectric slabs of T and D minus T. Now from here also we have to do one special case. What should be the special case? Let's see. What should be the special case? Here we can do many more special cases, and all the special cases are very interesting. You see, if you have not written this thing, so please pause the video here and write down. Special case number 1. If the thickness of dielectric slab is equal, that means d by 2. What we have taken? Now we have taken t and d minus t. Here it is told that you have to take the slab just like this way. This is d by 2 and this place is d by 2. Okay, the total length is d and here it is k1 and k2. So what will be the change of the value? Okay, so very simple thing is, instead of t it will be d by 2 and instead of d minus t it is also d by 2. Okay, so instead of taking separate thickness I am taking equal thickness here. So we have to mention here that, so t should be equals to d by 2 and d minus t, that is equals to d by 2. If I put the value here, what it will come, that c equals to epsilon naught a t1 t by k1, so it is d by 2 k1 plus d minus t by k2, so d by 2 k2. Okay, so d by 2 it will be taking as a common, and so 2 will come up to epsilon naught a by d into 1 by k1 plus 1 by k2. Okay, you see, parallel. Let's do it. So if you do it, 2 epsilon naught a into d, so k1 into k2 they will come up, and here at down k1 plus k2. Okay, so this is the capacitance if you take two equal thickness of slab. C equals to 2 epsilon naught a k1 into k2, so it can be written k2 into k1, same thing. Okay, by d into k2 plus k1. You have to remember it, from where it is coming, how it is coming, otherwise you cannot able to prove it in exam. So this type of questions will definitely come in exam, so be careful about that. Okay, so be practice more so that this type of questions will be very much easier for you. Okay, so we'll go for the second case. Okay, second special case. So it is special case number 1. Now we'll go for special case number 2. Now also we are introduced two dielectric slab, but in different manner. Initially we have introduced a dielectric slab just like this way. Now it is d by 2 and it is d by 2 like this way. Now we have to introduce some another way. How? We're introducing like this one. Okay, so it is the total thickness d. Earlier we have introduced two dielectric slabs, that is k1 and k2. Big problem. What we have to do? K1 and K2, two slabs are introduced, but not in this method. What we have done earlier is like this. Now you see, it seems to be like the series combination we have done earlier for the case of resistance, for the case of capacitance, that you see end to end contact, end to end. So whenever we have to calculate it once, we have to forget about another. So first you forget about this K2. Assume there is no K2, nothing is there. Then what we have to do? We know for parallel plate capacitor, C equals to K epsilon naught A by D. In the previous part we have seen that when a dielectric slab of full thickness D is introduced here, of K, of thickness D, if you introduce, then it will come K epsilon naught A into D. Now we have to use this formula here. Okay, first we have to forget about Q1. So for K1 capacitance, and now you see they are there if I am talking about the area, so for K1 the area should be A by 2, for K2 the area should be A by 2 separately. So for K1 capacitance C1 is equals to, you see what it will be? Now K1 into epsilon, instead of A we have to write A by 2, simple thing. K1 epsilon naught A by 2D for only K1. We are not thinking about K2. And for K2 capacitance C2 equals to K2 epsilon A by 2 into D. Separately we have done for this, separately we have done for this. Now you might be thinking, sir, instead of this, if it is kept like this way, K1, K2, K3, then also separately it will be divided A by 3, A by 3, A by 3. So it is K1 epsilon naught A by 3D, K2 epsilon naught A by 3D, and K3 epsilon naught A by 3D. Okay, and here it is 2, that's why we have written 2D, 2D. Now total capacitance C equals to C1 plus C2. Okay, so it is epsilon naught A by 2D K1 plus K2. Now you might be thinking, sir, for series combination of capacitors, the capacitance will be 1 by C1 plus 1 by C2. I am just telling it is not a series connection, but it seems to be like a series. So for that you will just think about the earlier concept of resistance. It is not a combination of resistance, a combination of capacitance also. So here we, as it is in series, we have to add it. Okay, so as we have added, this answer has come, that is epsilon naught A by 2D K1 into K2. Okay, so this is the capacitance, write it. Okay, now we'll go for the third special case. This is the special case number 2. Now we'll go for special case number 3. Okay, so for different introduction of that dielectric slab, how the capacitance can be changed. Okay, so this portion is not needed for us now. Now what we have to do? Assume if it is kept like this way. K1, K2, K3, D the thickness. See, a new thing. K1, K2 and K3. How we have to do that? If this type of thing has come, so here if I'm talking about K2 and K3, it is D by 2 and it is D by 2. How we have to do that? So first we have to start from K1, then we'll forget about K2 and K3. So for K1 capacitance C1 is equals to K1 into epsilon, as it is covered A by 2 portion. So epsilon A by 2 into D. Okay, so for K1 the capacitance we have already taken. Okay, now we'll go for K2. Okay, and it will occupy the space D by 2 and D by 2. Now I'll make you remember, whenever we have taken a capacitor of dielectric slab D by 2 and D by 2, K1 and K2. So in this case, the capacitance that has come, we have to remember it. Okay, so it is coming there that 2 into epsilon naught A by D into 1 by K1 plus 1 by K2. Just now we have done that. Okay, so here also we have done the same thing. So for K2 and K3, capacitance C2 is equals to, see, 2 into epsilon naught A. So from where this 2 has come? The 2 has come because we have taken it is d by 2. So we will write it that, you see, epsilon naught A. Okay, now A, though it is not here, it is A by 2. Here it is totally A, but now it is here A by 2, so it is A by 2 by d by 2 into 1 by k2 plus 1 by k3. 1 by k2 plus 1 by k3. Now you see 2 cancel out, that is epsilon naught A by d 1 by k1 plus 1 by k3. Okay, so if you multiply, you can write it here that epsilon naught A, it is k2, k2 into k3 by d into k3 plus k2. Now add this, these are added together, so total capacitance capital C is equals to C1 plus C2. So C1 is K1 epsilon naught A by 2D plus epsilon naught A K2 into K3 by D into K3 plus K2. Okay, now from here you can take common epsilon naught A by D. So if you take common epsilon naught A by D, so it will come K1 by 2 plus K2 into K3 by K3 plus K2. That is the capacitance. Okay, so maybe the calculation seems to be little difficult, but if you understand once, then whatever the slab is introduced here, I think there shouldn't be any sort of problem. Instead of K1, if it is also divided by K1 and K4, so for it you have to do separately this one, for this you have to do separately, and then you have to add it. Whatever the slab should be introduced, you can do it like this way. Okay, now we have to start another thing means, instead of dielectric slab, if we introduce a metal slab, instead of dielectric slab we have to introduce a metal slab, then what the things will happen, we will see it now.